Alright, so let's go ahead and review for quiz 7.1. This is going to go over ratios, proportions, and radicals, as well as parallel lines, proportional parts, and mid-segments. So the solo quiz, is going to go over 7.1 and 7.2. So I'm just going to go ahead and look at some proportions. So here I have a ratio set equal to a ratio, so we're dealing with proportions here. My goal is to solve for x, and the first thing that you should do is you're going to cross multiply. So what I like to do is say, okay, 5 times the quantity 3x minus 1, which is equal to 4 times the quantity 2x plus 4. Okay, so now I'm going to distribute. So I'm going to distribute on the left-hand side, and I'm going to distribute on the right-hand side. So 5 times 3x is 15x, and then 5 times negative 1 is minus 5. And I'm going to equal that to 4 times 2x, that's 8x. 4 times positive 4, that's 16. So then I'm going to, subtract both sides by 8x, so I am left with 7x minus 5 equals 16, so 7x is equal to 21, so x is 3. That's my answer, so x is equal to 3. Okay, and the question you might be wondering is, why do I have to put parentheses? Why can't I just say 5 times 3x minus 1? Well, when you're multiplying, right, so if I say 5 times 3x minus 1, I really mean that I'm talking about this one object or this one number here, right? If I were to say 5 times 6 minus 2, right? If I say 5 times 6 minus 2, I know there are 3 numbers that you can see on the screen, but really you're dealing with 2 numbers, because 6 minus 2 is 4, right? So you're really saying 5 times 4. 5 times 4, well, that's going to be 20. If I said 5 times 6 minus 2, you're going to get 30 minus 2, which is 28. Completely 2 different things here, okay? And that's the same case with, these 2 expressions that I just pointed out, okay? So remember to put those parentheses whenever you're multiplying a number with an expression like 3x minus 1, okay? Let's go ahead and do another example. I have another proportion problem, and you're going to do the same thing. It's going to be 4 times 3x minus 2, right? I'm multiplying that 4 and the 3x minus 2, and you're going to equal that to 2 times 4x minus 2. Okay? Alright, so what I notice here is I'm going to make a play, because look at this. I have a 2 and a 4, right? So 2 is on the right-hand side of the equation, and 4 is on the left side of the equation. I'm going to go ahead and make the play instead of the using the distributive property, which you can if you want to. I'm just going to go a little faster. I can cancel this 2 by dividing by 2 here on the right side of the equation, and then I got to do whatever I do on one side, I have to do on the other side. So that 4 and the 2, they'll cancel out, or more like 4 divided by 2. They're not going to cancel out. 4 divided by 2, which is going to be 2. So let me go ahead and say, okay, so these 2 2's cancel, so you're left with 4x minus 2. And then you got 4 divided by 2, which is 2 times the quantity, 2 times the quantity 3x minus 2. Then proceed to distribute. So you are left with, so I got negative 2x is equal to 2. Actually, negative 2, right? No, positive 2. What am I doing? And then x is negative 1. That's my answer. Okay? Check to see if I did my math right. So 6x minus 4, 4x minus 2, minus the 4x, add 4. Yeah, that should look right. Yeah, x is equal to -1. Okay? So, again, with proportions, remember proportions, they are two ratios that equal to each other. The goal behind solving proportions is that you cross multiply. Use the butterfly method or the baseball method or whatever your teacher told you to do. But it's really, you're just cross multiplying, okay? Very, very straightforward problems. If I were you, let me go ahead and give you a problem that you can do on your own. We can say something like 2x plus 5 over 10 equals 42 over 20. Go ahead and do that on your own. Pause the video, practice the solving proportions. Okay, pause the video right now, and then I'm going to give you the answer in a second. Alright, so the answer is x equals 8. Okay? So that's the answer for that proportion problem. Alright, here we're going to have some word problems. The ratio of the measures of the three angles of a triangle is 7 to 5 to 8. Find the measure of the angles, okay? So, number one, obviously read the problem very, very carefully. Figure out what you are dealing with. You're dealing with, well, one, the ratio. Or really, this is actually an extended ratio because it has three or more quantities here. So I have 1, 2, 3. So this is my extended ratio. That is 7 to 5 to 8. And you're dealing with the triangle. So I'm going to draw my triangle. And they're talking about these angles, okay? Now, 7, 5, and 8, it's a ratio, it's expressed as a ratio, not necessarily the angle measure. This is not 7 degrees. This is not 7 degrees, 5 degrees, 8 degrees. So I'm going to go ahead and put, let's say 7 here, 5 here, and 8 there. Okay? Once again, it's not 7 degrees, 5 degrees, 8 degrees, because it doesn't make sense, because we all know that the sum of the interior angles of a triangle, so sum of the interior angles of a triangle is always 180 degrees. If I were to add 7, 5, and 8, that's going to give you 20, right? So, and 20 is not 180 degrees. So really, what am I supposed to put here, here, and here? Well, I'm going to put x here, x here, x here. Then I'm going to set up my equation. Okay, so these angles should equal to what? 180 degrees. So then you have 20x equals 180, so x is equal to 9, right? So if x is equal to 9, what am I supposed to do with that, once I solve for x? Well, I'm going to have to plug it in. I'm going to plug it in to here, to here, to here. So 7 times 9 is 63 degrees. 5 times 9 is 45 degrees. And then 8 times 9 is 72 degrees, right? So these angles, 63 degrees plus 45 degrees plus 72 degrees, does that, I'll pull up my calculator right now, does that equal to 180? If it's so, then x is equal to 9, okay? So let's see, 63 plus 45 plus 72, that's 180, so that's right. Okay, so x is indeed 9. You solve for x, and then checking your work to see if that's equal to 180. Good. Now, what am I supposed to do? Well, you already figure out so you've already found the measures of the angle. So it's 63 and 72 as well as 45. That's good. Now, let me go ahead and express this as a ratio. So I have 63 to 45 to 72, okay? Now, this is an extended ratio, but remember, back in the notes, we said that ratios must be simplified, right? So, I can't leave this as a ratio because it's not simplified, right? It's like saying, okay, I have 6/3. That's a ratio. But what's the problem with this ratio? It's not simplified. So what goes into 6 and 3 at the same time, right? It's going to be 3. So if I divide the top and bottom by 3, that's going to be 2/1. So this is my simplified ratio. So going back to the 63, 45, and 72, well, what number goes into 63, 45, and 72 at the same time? That's right, it's going to be 9, right? 9 goes into 63, 9 goes into 45, and 9 goes into 72 at the same time. Hence, if I divide this by 9, I get 7 to 5 to 8. And there you go. Okay? That's a great way to check your work too. Alright, so that's something that you can expect on the quiz, perhaps. If I were you, I would definitely go back, do this problem without the work shown, and try it on your own. Okay? Because really, what is the goal? You're going to find the measures of the angles, and basically you're going to draw your triangle, label the angles, and then, or not label the angles, but include those numbers there, and then find the measure of the angles there. Okay, so let's go ahead and take a look at this one. The perimeter of a rectangle is the ratio of the length to its width is 5 to 2. Find the area of the rectangle. So first thing I want to make sure that we all understand the perimeter. It means the total distance around the figure. Okay, and if we're talking about the perimeter of a rectangle, that's equal to 2 times the length plus 2 times the width. So here I'm gonna go ahead and draw a rectangle. Here's my rectangle, and if I were to talk about the perimeter, I'm going around the figure. Okay, or in other words, I'm going to add all these sides up. That's the perimeter of the rectangle. We call this the length, we call this side the length, and we call this side the width. Okay, and if this is the length, this is also the length, right? So I call that the length, and then here's my width, so that's also the width. So how many L's do I have and how many W's do I have? Well, I have 2 L's plus 2 W's, so you add them up, you get your perimeter here. Okay, so the perimeter of a rectangle is the ratio of the length to its width. Is 5 to 2. Okay, so it's saying length to width. So this is the length, this is the width. So I'm going to call this 5. I'm going to call that 5. But is it really? Oh, sorry, not 5 here. It's actually 2. I should use a different color, something lighter. So this is 5 and this is 2. Okay, but is it really 5 and 2? No, because it's actually a ratio, right? So we're going to put those x's like we did in the previous problem. So x here, x here. So I have, if I plug it in, it's 2 times something plus 2 times something. This is going to go, that's going to be my length, and this is going to be my width. We already know what the length is, right? So the length is 5x. So I'm going to go ahead and put my 5x here, and then my 2 times this width. W is 2x, so that means I'm going to put 2x there, okay? And then, one more thing before I forget. Oh, wait, what happened here? Usually it's supposed to give me the perimeter. We actually need a number here, so let me go ahead and say the perimeter of a rectangle is 98 feet. Okay? So the perimeter of a rectangle is 98 feet, and the ratio of the length to its width is 5 to 2. Find the area of the rectangle. So the perimeter is actually given, it's 98 feet. So my perimeter of the rectangle, I'm going to replace that with 98, okay? So now that I have a proper equation to work with, I can go ahead and solve for x. But the first thing I need to do is figure this out. 2 times 5x is 10x plus 2 times 2x, that's 4x. So 98 is equal to 14x. I'm going to put that in my calculator. So x is 7. That's great. That's awesome. X is equal to 7. So then what do I need to do? I'm going to have to go find the length and the width. So 5 times 7, that's 35 degrees. And then 2 times 7, that's 14. Okay? So I already figured out the length. The length of the rectangle is, oh, I didn't mean to say 35 degrees here. That only applies to angles. It's 35 feet. It's 35 feet, and then this is 14 feet. So length is 35 feet, and the width is 14 feet. Okay? But the question is asking you to find the area of the rectangle. And the area of the rectangle formula, so that's going to be length times the width, okay? And we already know what the length is. It's 35 feet times 14 feet. So I have 35 times 14. That's 490. And then I have feet times feet. So this is current. So a length and the width are both in one-dimensional line, right? So it's feet to the first power. But when you're getting into the area land, you have feet times feet, which is feet squared. So that's going to be feet squared. It's kind of like saying, okay, x times x, that's x to the first power times x to the first power, or x to the first power plus 1. And that's x squared. And you learned that from Algebra 1. Okay? So the answer is 490 feet. Alright. So that was a lot, but you really, really need to understand how to do this problem. You got to read the problem. You're going to have to visualize the problem. You're going to have to set up the problem. You're going to have to plug things in. So please make sure that you are comfortable with doing this and getting faster doing these types of problems, okay? Alright, now we're going to get into this territory. I have some radicals here, and there are 2 square root of 50s. I apologize, but there's a reason why we have 2 square root of 50s here, because I want to show you 2 methods that we taught you, and we're going to review them. One of them was, okay, you have the radicand, right? So 50 is the radicand, and I'm going to break it up. I can break this up into the square root of 25 times 2, right? 25 times 2 is 50, and I'm going to rewrite this. That's going to be square root of 25 times the square root of 2, okay? And then we know what the square root of 25 is, because if I put that in my calculator, you will get a nice number. That's going to be 5. And then you can't take the square root of 2, but, well, you can. You're going to get a decimal, but you're not going to get a nice number like 5 here. So square root of 2 is just the square root of 2. So that's my answer. So this is, I'll call it method 1 from the 7-1 notes. Over here, I'm going to show you the buddy system method. You're going to draw a factor tree. So here I'm going to draw a caret sign, and then I'm going to think of 2 numbers that multiply together. They'll give me 50. That's going to be 25 and 2. And then here's this 25 here. I can break that down into 5 and 5. And since I have a pair of the same, number, I'm going to circle that and underline the number that, or the numbers that don't have a pair, but I only have one prime number here, which is 2. So that's going to be underlined. So what I'm going to do with this pair, well, first of all, I'm going to draw my square root sign. One of these 5s will go away, and the other one will be taken out of the square root. Okay? So I'm going to eliminate this 5, and bring this 5 over here. Okay, so that's going to be 5 root 2. And that's your answer, just like this. Now, this method is really this method here, but I think this is fun to do. All right. Let me go ahead and take a look at. Perhaps you're gonna get something like this. Perhaps you're gonna get something like. Alright, so maybe you'll get something like 10 root 98. Okay, I'm gonna use the first method, and then I'm gonna use the other method. Same problem, 10 root 98. So I have 10 times the root 49 times 2. Say 10 times 49 times root 2. So then 10 times, what's the square root of 49? Well, that's 7, and then the square root of 2, well, if I put that in the calculator, you're going to get a decimal, right? 2 is not a perfect square, so I'm going to leave it alone. So 10 times 7 times root 2, and I'm going to multiply these coefficients here, okay? So I multiply the numbers that don't have a square root, so 10 times 7 is 70 root 2. So 70 root 2. So that's method 1. So if I do the same problem and do the buddy system method, okay, it's going to be 49 and 2, 7, 7, circle, that's, circle the 2 7s here, eliminate 1, and then bring out the other, and that 2 is our prime number, is going to stay inside of the radical, okay? So you will get 10 times 7 root 2, so 70 root 2. Got it? Alright, let me do some more examples. Square root of 63. So doing the buddy system method, let's say 9 times 7. And then here I got 3 and 3, so I'm going to eliminate one of the 3's, and I'm going to underline that prime number there because that 7 is going to stay inside of the square root, so 3 root 7. That's my answer. Okay? And then the other method would be root 9 times 7, or root 9 times root 7, so 3 times root 7. Hence 3 root 7. Just like so. Okay? Let me find that problem where you have 2 prime numbers in case you have something like that, or you're, dealing with that type of problem. Okay, so I believe that is 5 root 84, okay? So I'm going to do the buddy system method, the factor tree method. I think of 2 numbers that multiply together, that'll give me 84. That's 4 and 21. And then this 4 can be broken down to 2 and 2. And then this 21 can be broken down to 7 and 3. Okay? So then here I can circle the pair of 2's, and I'm going to eliminate one and bring out the other one. So that 2, so this 2 here is going to go outside of the square root. So I have 5 times 2 root. And then what do I put inside here? Notice that this 7 and this 3, the 7 doesn't have a pair and the 3 doesn't have a pair. And when I'm talking about a pair, they have to have a, they have to have the same number. So there needs to be another 7 and there needs to be another 3 for that number to go outside. but in this case it doesn't. So what do I do with the 7 and the 3? They're going to go inside of the square root, and they're going to be multiplied. Okay, so 5 times 2 is 10, root 7 times 3 is 21, so the answer is 10 times the square root of 21. Okay, so that's how you're going to do that problem. Now I'm going to go ahead and move on to some other topics. Let's say you're given something like this. We're going to label this A, B, C, E, and D, where AB is 6, BC is 4, and AE is 9. Find ED. Okay, that's your goal. You're going to find what ED is. So now I'm going to go ahead and label. This is 6, this is 4, this is 9, and my goal is to figure out how long this segment is. So what is the measure of that segment? I'm going to call ED, so we're going to say let ED be X. So this is now X. And notice with our triangle here, we have a segment that is parallel to the third side of the triangle. You're going to apply what we call the triangle proportionality theorem. The triangle proportionality theorem states that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So if I have this parallel to this, and when we're dealing with the triangle here, you're going to take the ratio between this and set that equal to the ratio between this and this, okay? And you're going to say, okay, well, I'm going to take the ratio between this over this, so I'm going to write 6 over 4, and you're going to set that equal to, well, since 6 is up top, it needs to correspond with that other side. So here I have 6 and it corresponds with this 9. So 9 needs to be up top. You have to be very, very consistent. And that's going to go over X because 4 is in the denominator, and 4 also corresponds with that X. So X needs to be in the denominator for this fraction. Now you can see that we have two ratios that equal to each other, so that means you're dealing with the proportion. So 9 times 4 equals 6 times x, so that's 36 equals 6x, x is equal to 6. So that means that ED is 6. That is how long ED is, so that's 6, okay? Again, if we're trying to find something, we're going to call that x. So let nz be x. And we know that xn is 6, nz is x, xm is 2, and then, ooh, look at that, xy is 10. Okay? So, yes, you're going to apply the triangle proportionality theorem here, because you can see that the segment is parallel to the third side, okay? And there's no value here and here, so you're gonna say, okay, I need to create a ratio between these two parts and set that equal to the ratio between these two parts. But notice something. This whole thing here is 10, and this here is 2. But I can't create a ratio with 2 and 10. You have to create a ratio between this part and this part. So if this is 2, how long is my? And yes, I know this is not drawn to scale, so my apologies if this, looks a lot smaller than this. So it's 2 plus, let's do the math, of 2 plus that part, and I'm calling this thing the part. I'm going to solve for it, and it's equal to that whole thing there. If I subtract both sides, that part is actually 8, right? So this is 8. And I was applying the segment addition postulate there. Part plus part is equal to a whole, right? 2 plus 8 is indeed 10. Now that I have that, I can go ahead and use these numbers to create my equation. So it's going to be 6 over x, which is equal to, since 6 corresponds with 2, 2 is going to go up top, and then x corresponds with 8, 8 is going to go on the bottom. So 6 times 8 is equal to 2 times x, 48 equals 2x, so x is equal to 24. So x is equal to 24, that means that NZ is 24. So NZ is 24 units long. Okay. Well, I think we can do. So let me go ahead and just label everything. WX is 7, WY is A, and then WV is 6, and then VZ is A minus 9, okay? So again, we're going to apply the triangle proportionality theorem here, and I need to create a ratio between these two parts, and I'm going to equal that to these two parts. But notice that we don't have anything here. So again, we're going to use the segment addition postulate. Remember, segment addition postulate is part plus part is equal to a whole. So we're going to call this our part here, the thing that we're going to be looking for. So 7 plus that part, right? So our part plus part is equal to the whole, which is A. I'm going to solve for the part. So what do I have to do to get, the part by itself? Well, 7 is in the way, right? So I'm going to subtract both sides by 7. So the part is equal to A minus 7. A minus 7. So x, y is A minus 7. So then now I'm going to go ahead and create that proportion now. So it's this over this equals this over this. So 6 over A minus 9 equals 7 times A minus 7. Then I'm going to cross multiply. So 7 times A minus 9 is equal to 6 times A minus 7. So 7A minus 63 is equal to 6A minus 42. So then we'll subtract both sides by 6A. A equals 21. So A is equal to 21. Okay? So if A is equal to 21 and we let WY be A, that is how long WY is. That is how long WY is. Okay? Alright, so let's talk about midsegments. Midsegments, they are 1/2 as long as the third side. So if I were to say something like this, and we're going to say that segment JH, segment JP, and segment PH are the midsegments. And we're going to assume that's true. So assume that segment JH, segment JP, and segment PH are midsegments. Well, how long is KM? Well, if we know that PH is the midsegment, right? And we're going to call that midsegment. We're going to give it a value. We're going to give it a value of 14. Then how long is KM? Well, if this is 14, right, then this has to be 28. I'm going to go ahead and verify that with you. So we say that PH is 1/2 of KM. And we know that PH is already given. That's 14. And I'm going to equal that to 1/2 KM. So what do I have to do on both sides to get rid of this 2? Well, I got to multiply everything by 2. So you get 28 equals km. Okay? And that's really, really simple. All you have to do is you take this number and you multiply that by 2, and you will get km. And you don't really need to do all this work here, because if you can see it, that's wonderful. But if I were to say, okay, let's call this 30. If this is 30, then how long is pH? Well, that's going to be 15, okay? Let's do some more so we can see it. If I call this 20, how long is km? That's going to be 40. If I call this 40, how long is km? That's 80, and then you get the drill. Hopefully that makes sense, okay? So mid-segments is equal to 1/2 the third side. You actually have to know that formula, so make sure that you have that somewhere, and be comfortable knowing how to calculate mid-segments or that third side, okay? Alrighty, so let's say you are given something like this. So notice that we have 3 parallel lines cut by 2 transversals, okay? And notice that we have 3 parallel lines cut by 2 transversals, and the fact that we have a tick mark here and a tick mark here. If that's the case, you need to draw those 2 tick marks on the other side, because you can go ahead and create an equation. Since these 2 segments are congruent, I can set them equal to each other, and I can do the same thing over here as well. So I have 20 minus 5x equals 2x plus 6, and then I have y equals 3/5 y plus 2, and then I'm going to go ahead and solve for this one. You get 14 equals 7x, x is equal to 2. Okay? And then over here, this one's weird because it has a fraction, and I want to eliminate that fraction. So I'm going to multiply, again, like before, I see this 5 here, I'm going to multiply everything by 5. So I have 5y equals, so these 5's cancel, 3y plus 5 times 2, so 5 times 2, that's 10, and then I get 2y equals 10, y is equal to 5, okay, and that's your answer. And whenever, just to note, whenever you're multiplying by the number that's in the denominator, so here I have that 5 that's right here, you're going to distribute. So yes, when I'm multiplying 5 and the 3/5, these 5's will cancel, but don't forget to multiply the 5 with the 2. Okay, so you should have 5y is equal to 3y plus 10. Do your algebra, hence y is equal to 5.